Okay, so Leetcode practice time. Two goals, similar to my other videos. The first one is to find the solution for this problem and put in some solid code there. And the other one is to see how to behave during an interview. Suppose this problem is given. So let's get started. Keep in mind the first step in coding interview, it is always to try to understand the problem, what the question is asking you to do, and also ask some clarification questions in case there's anything that is unclear to you. And also at the same time, think about some edge cases that you need to take special care of. So let's get started to understand this problem. So it's called power xn. So implement the power xn, which calculates x raised to the power n, okay, which is x to the so x powered n, okay, x, well, how is it called, x to the power of n. Okay, so example 1, we have x equal to 2, n is equal to 10, so it is going to return 1024. And similarly, if it's 2.1 and a is equal to 3, then it's 9.261. And for this one, when it's a little bit special because n is smaller than 0, then it is 1 on 4, which 1/4, which is 0.25. Alright, so let's see the constraints. X is going to be between minus 100 to 100, and n is between 2 to the minus 2 to the power of 31 to 2 to the power of 31 minus 1. Alright, so xn is between minus 10k to 10k. Okay, so I think I mostly understand what the problem is asking us to do. So the next step is to find the solution. And by the way, I didn't see too much of the edge case. I would say, if you want to see some special edge case, maybe when n is equal to a 0, then it is going to return 1. Other than that, I think it's pretty normal. So let's see, find the solution part. So for the finding solution part, of course there's a brute force solution there. You could multiply n x n times. It is going to be all of n, which is not good. And the other thing is, it's kind of like how to call it. It's similar to binary search, but it's not actually binary search. So the thing is, when you compute, when you have already compute x to the power of n divided by 2, you can just simply reuse this number. So let's define the half as this one. So if x, so if n is if n mod by 2 is equal to 1, then actually you just need to return half times half, and then times x, or 1 on x, depending on whether n is a integer or not, is a positive integer or negative integer. And if return this one, and otherwise we just need to return half times half. So in this way, the runtime is going to be O log n. So I would say this one is definitely better. Let's get started to do some coding work on this approach. So the next part is about coding. So in this part, don't be too slow, and also take care of your correctness of the code, and also the readability of the code. So let's put some code here. I would say some special task is, so if n is equal to 0, we just return 1.0. And so if x is actually a 0, what to do? So if x is actually a 0, then we pretty much just return 0. If x is equal to 0, then we just return 0. And otherwise, if n is equal to 1, then return x itself. And if n is equal to -1, then you return 1 over x. So that's it about the edge cases. Let's see. So we will compute the half, and it is my power x on top of n divided by 2. So if half modular 2 is equal to 0, then we simply return half times half. Otherwise, we need to return half times half times, so if n is larger than 0, we just times another x. Otherwise, it is 1 over x. 1.0 over x. Okay. Yeah, so I think that's it. Let's do some testing after coding. So after you're done with code, you need to go through a sample example to see how it works, and at the same time explain how this piece of code is going to behave on top of that example. And after that, think about setting some task cases to make sure that it could cover different branches. So let's say, for example, let's say if x is equal to 2 and n equal to, let's say, 5. So we are going to return 32 here. So let's see this one, x equal to 2, n is equal to 5. So half it, we are going to call half my power 2 and 2. So in my power my power 2 and 2, then we are going to call my power 2 and 1. So that one is going to give us a 2. And similarly, my power 2 is going to be 2 times 2, which is 4. And then 4 times 4, which is 16, and which is this part. And then n is larger than 0, and it's not an odd number, then it is going to times another x. Okay, so I think it should work, and similarly it should work for example 3. So let's give it a shot. Okay, so it's wrong answer. Let's see why. 2 to the power of 10. So x, maybe I made something. So if x and n, if x is equal to a 0, then return 0. If it's equal to 0, n is equal to 0, return 1 power 1, and n is equal to 1 is return x. Otherwise, yes, I think it should be fine. Is it this one? 1 over x. So half is defined using my power x and divided by 2. If half divide modular 2 is equal to 0, we just simply return half times half. Otherwise, it is half times another thing. I think it should. Oh, it's another wrong answer. Let's see. So if n is equal to 0, of course it's going to return 1.0. If n is equal to 1, of course returns x. If n is equal to a minus 1, of course it is 1 over x. Okay. Okay, and then we do the half thing. Oh, actually, there is a typo here. It should be n modular 2 is equal to 0. Yeah, that's a typo. So it's working now. Okay, so now it works perfectly. So like I said, for testing, do go through this piece of code carefully. So I didn't check it very carefully and I got a typo here. And also when thinking about setting up some edge test cases, think about some edge cases like potential edge case. So for example, if x is equal to 0, if n is equal to 0, and if n is a negative integer, n is a positive integer, so something like that to make sure that you cover different branches. And that's it for this coding question. So if you feel it a bit helpful, please give me a thumb up, and I'll see you in the next video. Thanks for watching.